Ladies and gentlemen, welcome to today's webinar, which name is From OpenStreetMap via PTV Visum to PTV Vissim. My name is Johannes Schleich. I'm Director for Product Management and Services for Traffic Software at PTV in Germany. Today's webinar is a bit different from other webinars, which often focus on a specific topic. Today, I want to run through all fields of transportation modeling which we cover with our software, or at least many of them. So that means I'm going to start in Visum, which is the macroscopic modeling tool, and then I will go to more the operational part, the microscopic modeling. And I'm going to do this during the webinar on openly available data from OpenStreetMap. So everything what I'm going to do during today's webinar is live, and you can do it the same way at home using data from the web. Also, for example, using our demo software, which you can download from the web. During the webinar, I will also at some points will show you some new functionalities in Visum. New means not just things from the latest release, but also things which we have added over the last 2 or 3 years and where some users might not be aware of. Also, feel free to ask questions during the webinar, depending on whether they might be interesting for a larger group. I will directly pick them up and answer them to the whole group. Otherwise, I will answer them later, either directly using the chat functionality from GoToWebinar or answering you by email. So you don't have to stay online to receive an answer. If you ask a question, I have your question connected to your email address, and then I can answer you later via email. So in terms of our traffic software, if we divide into strategic planning and operational planning, the main focus of our software is PTV Visum for strategic or macroscopic modeling, and then Vissim for more operational modeling. And these are the two software I'm going to present to you today. This is the agenda for today. In the first part, which is in PTV Visum, I want to start with an OpenStreetMap data, which I'm going to download from the web, and I'm going to end up with the assignment results and with analyzing these assignment results in Visum. Thereafter, in the second part, I will go from the Visum results, and this is not right in the slide, and then going over to Vissim by exporting a subnetwork from our OpenStreetMap data. Okay, then let's go directly into the list of things I want to show you today. So the first thing was to download OpenStreetMap data from the internet. For this, you can you have different options. One of the options could be directly to go to openstreetmap.org and then to click on export to export a certain area of the OpenStreetMap data. Here is an example from Shanghai, which I'm going to use during the webinar. However, with this OpenStreetMap website, you only can export smaller areas. So if you have a larger area, you need to download the data from another source. And here you can use different websites. One of them is geofabric.de. Here you, for example, can download by different areas. So if you click on Asia and then China, you can download the whole Chinese OpenStreetMap network. This is obviously a very huge data file. If you unzip it, it will be around 2 GB of data. Another nice website, which I often use for downloading OSM data, is this website. Here get the data ready to use by metropolitan areas. And here we also have OpenStreetMap data for Shanghai. And well, I did this before the webinar, just downloading the data for Shanghai. This is one file, and then we can use this file to be imported in Visum. Here we have, for the import in OpenStreetMap, we have a new functionality in PTV Visum 14. If you go to File, Import, and then OpenStreetMap, you can see that we now have the possibility clip network to bounding box. And here we now can enter different coordinates of the bounding box, and then Visum will automatically cut this bounding box from the OSM file. This is something you had to do earlier in a pre-processing step. And even nicer, you don't need to care about these coordinates. What you can do, you can go exactly in your Visum interface. You can go to this area which you are interested in, and then you can Visum will automatically take over the corresponding coordinates. For this, I'm going to change the map service for the background map. I can do this in the graphic parameters, and I change this to OpenStreetMap, as this is for me easier to navigate. And also interesting options we are having here, which I want to show you, are the possibilities to set the colors to grayscale. That can be sometimes good if you want to have more a focus on your map or on your links and nodes in the Visum network, and not so much on the background map. Also, you could reduce the intensity, again putting more focus on your network objects rather than the background map. I will leave it just to grayscale. And now, well, basically for me the most important, most difficult part in this webinar. Now I'm going to navigate to the area I want to have a look at in Shanghai. The reason why I'm using Shanghai is very simple. I was doing this presentation the first time for a client when I was in Shanghai, and then I was choosing an area which is covering downtown of Shanghai, and also at the same time which is covering the area of our office in Shanghai. So now I'm having this area of downtown Shanghai. For those of you which know the area, this is the river. You can see the Bund, which is the riverside area. Now I go to File and Import, and now I can choose one of the OpenStreetMap files which I downloaded previously, either the China, the China latest, which is whole of China, or just the Shanghai file. As it goes a bit faster, I just choose Shanghai. And now I activate this option, clip network to the bounding box. And now Visum will import only those OSM elements which are completely inside the bounding box. If I click on OK, now Visum will start reading the OSM file, will look for all the objects which are inside the bounding box and convert them into Visum objects. Here you have some more options and for configurations. So when importing OSM data, you always have to be aware of that this is crowdsourced data. So it might be that in some regions the coding of the OSM data is a bit different than in others, and therefore you have here different options for configurations. So for example, how OSM link types are translating into Visum link types, how the mapping of the OSM data to transport systems should be done. So this is something you can set during the import process. We have in our example, we have a couple of standard configurations, and I was using one of these standard configurations to import this network. Here you already can see the result. So it takes, as you can see, for such network maybe 1 minute. And we now have exactly this area imported, which we had seen previously with the background map. Of course, we again can activate the background map if we want to see it, and of course the coordinate system is perfectly fitting to our Bing background map. As I said, during the import we are creating real Visum objects. So for example, each link which was previously just on a map is now a real Visum link with all the attributes you are expecting from a network, from a transportation modeling network. So you get information on the speed, you have information on the capacity, and also some other information like the length. Here we sometimes have to guess values from the OpenStreetMap data. You also can see in the user-defined attributes, you can see the original information from OpenStreetMap. When looking at at an example, for example here, this bridge, we can see that here the bridge, for example, does not allow bikes, does not allow pedestrian, which of course makes sense. So here the coding in the OSM data was pretty good, giving us also good results for our transportation modeling network. We also can see this if, for example, we run a shortest path search. So we do this from node to node. So if we run it from one part to the other part in our network and then maybe again into another direction, and then with a last stop downtown, we can see that this is now the routing for the transport system bike. If we change this, for example, to cars, we can see that now this bridge with a crazy, quite crazy access circle or access ramp is now used for the cars. And switching back again to bikes, we can see that now another bridge is used, which is open for bikes. Okay, if we now, the goal of the first part of this webinar was to see assignment results in Visum, and one important input for such an assignment is of course traffic analysis zones, or we just call them zones in Visum. So we need some kind of a zoning system, and here again the OpenStreetMap data can help us, because OpenStreetMap comes with a lot of points of interest. So you can see we have a total of roughly 900 points of interest in the Visum data. And if we have a look at the list, we can see that we have signals, public parking, water, industrial, residential areas. So we have different POI categories being imported into Visum. We can get an idea about these POI categories, and this is also a new function by opening up this little menu. You can see all POI categories. We have three main categories: administrative, land use, and traffic infrastructure, with a couple of subordinate categories. So if we want to use if you want to use some of these points of interest for being zones in our transport model, it certainly makes sense to use, for example, the land use data, which can be things like residential as origin, or pedestrian zones for shopping as destination, or industrial as well as destination of trips. So since also a quite new feature is that we can convert different area objects to other objects. So we now want to convert these land use points of interest to zones. For this, we first create a filter. So this filter will filter all points of interest from the category land use, which have the category numbers 21 to 25. And now with the right mouse click on the POIs, we can convert these active POIs. And during this conversion, now Visum will create from these points of interest zones. If we choose, now you can see the dialog. There was a little bit of delay in the transmission. During this conversion, you can choose details on how to deal with conflicts. So if a zone with a number is already existing, how Visum should react. As we're not having zones, we can skip this part. So we just now create from the active zones, from the active points of interest, we create now a total of 227 zones. And now when we look at our to-do list in the presentation, now we need to make sure that these zones are connected to the network, which means in modeling worlds we need to create connectors from the zone centroid to the network. When we want, for this also Visum has an automatic functionality. With a right mouse click on connectors, you can open the menu for connectors, and here you have an option, create connectors. Here you can choose whether you want to connect for private or public transport. We're just focusing on private transport. And what will happen after activating this functionality, Visum will search for active nodes around each centroid and will connect them to the specific zone. For public transport, I want to show you just another functionality to create a more clever way to create connectors. Under Visum add-ins, you will find a possibility to generate public transport zone connectors. This is an add-in which comes with the installation, so it's automatically installed. And here you have advanced options to consider the lines, also to use barriers. So if you click on help, you will see how this more advanced functionality work. So if I'm scrolling down to one of the examples, we are having here a barrier being considered. This can be, for example, a river, and then the connectors will consider this barrier and will connect the zones to other parts of the network. But for our example, for private transport, we just use the standard functionality to generate connectors. Here we just have to be aware of that we connect the zones to nodes which are also relevant for the network. So we don't want to connect them, for example, to a pedestrian area. And for this, we need to filter relevant nodes. This can be done by activating the filter of nodes. And here I again want to show you not completely new, but rather new functionality, which is here the column of relations. Per default, this is on nodes, as we are in the filter of nodes, but we can set this relation also to other network objects, which means we can set this, for example, to inlinks, which means now we are going to filter nodes, but based on the links which are incoming. Just let me proceed, then you might understand this better. I'm choosing now an attribute of the links, and I'm choosing type number, and within the type numbers I'm going to choose the major links from type number 2 until type number 39. And now I can set this to 1. And how can you read now this filter? So you filter all nodes where at least one incoming link has a type number which is contained from type number 2 to 39. So using this relation, you can directly filter nodes based on the attributes of links. This is something you had to do previously using combined filters. So you first filtered the links, and then you said you filtered the nodes by the number of active incoming links. But this is of course much more convenient and easier if you can do it right away within one filter dialog. Additionally, I say the links should contain the transportation system car. So with this filter, we can see it by the blue dots. We now have filtered the main roads or the main and their corresponding nodes. Now we can create connectors for this. So for example, we create 3 connectors in this step. Click OK. This is taking a few seconds, and then we can see that all of the zones are connected to the network. And maybe we can repeat this, also creating additional connectors for some smaller links. Why it's so important to spend a bit of time on the connectors. First of all, of course, connectors and the connecting times are an interesting value for transportation models, in particular also for demand models. The second thing which is interesting for us is that we have to make sure that our network is connected. When we later run an assignment, we need to make sure that each OD relation, for each OD relation, Visum can find a path. And some of you might know this this warning message during assignment. Visum cannot find the path from origin 1 to destination 2. And this happens if the network is not connected. Of course, we could now proceed and see whether our network is connected or not during the assignment. But I want to test this directly now before running the assignment. Using a good function which we have in Visum, which you find under Calculate, which is called Network Check. You can see this is a quite extensive functionality. You can check, for example, for isolated nodes. You can check for nodes not being connected for private transport, and many other options. I'm now mostly interested in checking the network consistency between all zones for the transport system car. And now I can run the test, and now I get the message, okay, the network is consistent between all zones. So luckily, also during this presentation, this worked out. It can happen if you import data from OSM that you have some isolated part of the networks, and then you will not have consistency already with the first guess of connectors. Then you will have to check them manually. But for us, we are fine like this. And now for running the assignment, we need one more thing, which is creating a matrix. Here, of course, we're not having realistic values. So I'm just creating one matrix, one demand matrix, and enter for all of them just the value of 5. Again, just for demonstration purpose, of course, this is not realistic. Finally, I need to assign this matrix to our demand segments of car by choosing this matrix number 1 for the demand segment car. Now, next step in our process is to run the assignment. So here, Visum offers a large number of assignment methods. One, and the newest one since already a couple of years, is the Luce assignment, which is a very sophisticated assignment as it reaches very good convergence in a rather low number of iterations. And Another advantage is, in particular for urban area, also in particular if you want later to go to a Vissim simulation, is that in cases where there are different options between origin and destination, like in this example where there are two possibilities coming from A and B going to D, that it keeps what we call proportionality at this node number 1. So for each relation A to D and B to D, 25% will use the northern route and 25% will also use the southern route. With other equilibrium assignment methods, you will not reach this proportionality. Another advantage of this equilibrium assignment is that you can use you can use multi-threading. So for example, you can use like 3 or 4 zones being balanced in parallel. If we run the assignment now in Visum, I choose cars. You can see we have a couple of assignment methods. I just explained Luce. Other things which are sometimes used for urban areas are stochastic assignment, the assignment with ICA, which considers junction details. I'm, for example, now going to choose the Lose assignment, which has one big advantage. It is a rather quick, running very quick, so it just takes a couple of seconds. Thereafter, we can look at the assignment results for our network, and we see here the volumes on each link. And of course, there are also other views on this. I prepared another one which shows the volume, but with a categorized view on whether the capacity ratio is more or less than 100%. It's just one question. No. Okay, just answering directly one question to all of you. Of course, this more or less than 100% is not fixed. So the question was, can we also show yellow? And of course we can. If we go to the graphic parameters of the link bars, we can go to the option use fill classification, and then we can change the filling as we need it. So just changing the values and say if we have less than 80%, we show it in green. If we have less than 100%, we show it in yellow. And for more than 100%, we show it with red color. So this is very flexible. I just was showing a predefined graphic parameter. Of course, you now can run also accessibility studies looking at isochrones. Just showing you one example. We can run isochrones, which gives us these kind of accessibility plots. So, for example, the accessibility to the next mall, or the accessibility to the next train station. Finally, when going more into the details, we also can have a look at turn volumes. Here, by activating different links, different nodes, we directly can see the typical drawings for turn volumes, and thereby we can analyze how many people are going straight ahead, turning left, turning right from each approach. And of course, you also can export. You can export turn volume into JPEGs and other formats in order to analyze them in other software, or also to put them into your report. Finally, another option to analyze the results are lists. Just showing you one example. If you right mouse click in the network toolbar on links, you can open the list for links. And again, I have a predefined predefined list here to analyze the vehicle hours traveled in the network. Here you can compare the vehicle hours traveled in the unloaded network with the vehicle hours traveled in the loaded network, and then you can see the difference. Also nice, rather new functionality in such lists is that you can group them, for example, by type number, and then you can analyze by type number, so by motorway, by urban roads, etc. You can analyze where the delays are occurring. So then you, for example, can see that for link type 31, a major amount of delay, like 10,000 vehicle hours, is occurring, which allows you then to go into the next step of analyzing and optimizing your network. So this was the first part of the webinar, focusing on Visum. So we have learned how to import OpenStreetMap data, then being able to use the data directly for shortest path search, for accessibility studies. We have seen how we can use points of interest and convert them into other area objects, for example, zones. We have seen how to automatically create connectors, and finally to run an assignment for such network. Again, just repeating this, of course, this is not a realistic example. This is just for demonstrating the possibilities within Visum. Now, we want to make the next step and take this network into Vissim. Therefore, of course, the full network might be a bit big to run it in Vissim. Usually we just want to focus on a certain area in our network. And now I want to define this area by a predefined shapefile, which I can import into Visum. Shapefiles is a common exchange format for objects used in GIS systems. So it can also come, for example, from other departments of the city government. Now going to import the shapefile, I can choose which object we should read the shapefile. I'm going to read this as a territory. Now again demonstrating something new in Visum. We now have available the fuzzy surface alignment. Here we could now, if we were having other territories already in the network, we could align the boundaries to a nice fitting boundary of the different territories. In our example, we don't have this, but this can be very helpful. For example, if you run analysis on territories and calculate territory indicators, it is good if they perfectly match to each other, if they are not overlapping or if there are not holes in the network, in order to always to get like 100% vehicle hours for all territories. In our case, I'm just importing the territory, and we can see it here. And now we can see the study area for our microscopic simulation. If I want to export this to Vissim, I need to run different steps. First, I need to create a subnetwork. I need to rerun the assignment and then export it to Vissim and again import it in Vissim. However, this is available also more seamless by the function INM export of a subnetwork. First, for this, we need to define the subnetwork. For this, we use the spatial selection mode, and now we could somehow manually define the area which we want to export, but for the purpose of being able to reproduce the result, I recommend you to use the functionality of mark objects in a territory. And now just click on the territory, and now all objects within the territory are active. The advantage is if you have to do it again and again, or maybe you want to use the adaptive A&M import later, then you will always have the same objects for the export being marked. Now we can run the export, and here we just use some standard parameters for the subnetwork generation, and also for the A&M export I was just choosing some names for the files but not changing any other parameters. If I click OK, it will now first run the subnetwork generation, rerun the assignment, and now the Vissim will automatically start in order to have a look at our result in Vissim. Sometimes this is starting, this takes a bit longer to start. Okay, here we can see the result now, and what we can do is we can now run the simulation for this network, and what we can see is that the demand has come to is also now in Vissim. So we have lots of vehicle inputs being created and also lots of vehicle routes. What we also can see is that we don't have any intersection control. So we neither have conflict areas nor we have signals. The reason behind this is rather easy. We have not defined them in Visum, so of course they cannot be in Vissim as well. So if we want to add additional information into Visum, we have to go back to Visum in order to add this kind of information in Visum. Visum has here the possibility of the junction editor. The junction editor allows you to add geometry information for Visum. In Visum for each junction. This geometry does not only contain things like number of lanes, you also can add information on signal controls. And this is what we want to do now in our example. So we switching back to Visum. Here in Visum, we again see our network, and now what we can do are two things. First of all, we're going to give a control type to all of the nodes. So we can change this using multi-edit functionality, and we can change the control type constantly here in our case, first of all, to a two-way stop intersection. And now all of them are two-way stop controlled, which means for the export, Vissim will automatically generate conflict areas using the hierarchy of the streets. And secondly, I want to do some extra modeling on one of the junctions. So I'm double-click on one of the junctions to open the junction editor, and now I can change the geometry for this junction. So for example, I can add for the eastern approach, I can add a left-turning lane pocket, and can give this lane pocket, let's say, a length of 50 meters. And as I said, we also can add signal timing information. For this, I'm going to add a signal controller for this specific junction for, let's say, 120 seconds cycle time. And now in the signal timing, I can create signal groups, one for the east to west direction, which basically can have green all the time for this intersection. I can create another signal group for the Western approach, which has green, let's say, from 0 to 60. And finally, I can create for the left turner from east to south, I can create this third signal group, which has green from 65 to 115. And if I'm going, now I need to go back to geometry in order to assign the signal groups to the specific lanes. So here the left turner will get the east-south, the third signal group. This one is the first one. And finally this one, the second one. And now we have these three signal groups being assigned to our network. With this little button of the Vissim preview, we can open this specific junction in Vissim, giving us a preview how it will look like after exporting it to Visum. This now again is opening a network, the network in Vissim, and here we now can see how our junction will look like in the import into PTV Vissim. This is quite helpful as it gives you a quick feedback whether your modeling will look the way you want to have it in Vissim. Now again, we can now again start the export to Vissim in order to see whether everything will arrive as we are expecting it in Vissim. So I again activate the subnetwork, and I'm again starting the export into Vissim. So now we need to start. Vissim will start it automatically. And again, we can see the results being displayed in Vissim. I'm switching off the background map in order to see more of the details. Now we can see that we have the conflict areas being active for each of the links, each of the nodes, and for our specific node where we had modeled some more details, we also can see that we have the left turning lane pocket. And if I'm switching off the conflict areas, we also can see that the signal control has also went from Visum to Vissim. Of course, for a real example, we now would have to code all the junctions in Visum and export them into Vissim. Of course, not everyone has Visum available or is able to use Visum, so there is still many people will just set up the network in Vissim, which is also quite convenient using the new functionalities, which we're going to show also to you in some more Vissim webinars. However, if you have the chance to start in Visum, you can see it can give you a quick start into your Vissim modeling. If you just look, for example, at the list of the conflict areas, you can see here that already more than 1,000 conflict areas are existing in this network, and they are already preset using the different values from Visum. And also, if you look into the vehicle routes, you can see that here it saves you some time to create the vehicle routes in Vissim if you can take them over from Visum. So with this, I'm coming to the end of today's webinar. My goal was to show you how smooth you can use Visum and Vissim to import data to convert the data, to export it from Visum to Vissim, and which can be quite helpful for you to run your projects efficiently. So sometimes if you're not having any network information in this and you want to run a Vissim project, maybe it can help you to bring the data from OSM to Visum and directly then to Vissim, and then you still can choose where you're going to add information on, for example, the demand, where you're going to add the information on the signal control. So this depends on your project. This also depends on your skills on the different software, and this also depends simply on your preference. Now, I would just want to show you, before answering some questions, I want to show you where you can get additional information. One of the sources, of course, is our website. On our website, you can download trial versions of our software. You can get information on training courses. In the installation of Visum, but this is also true for Vissim, you can get information from the overview document, what it's new. You can, or you can browse through the examples, and that's why I'm pointing to Visum. In Visum, we also have an example for OSM import, and we have an example for ANM. So the ANM tutorial, which shows you more extensively the possibilities of the export from Visum to Vissim. If you are then more interested in Vissim, I recommend you to browse to our website. So I'm now just directly opening the website. Here, if you go to Community and Webinars, you will find more webinars upcoming for Vissim, like efficient model editing with lists, and another webinar which is maybe quite similar to today's webinar, also starting from nothing and Vissim, and then creating a signalized intersection from the scratch. This is going to happen on 17th of February. So if you're not yet registered, just register for this webinar. Well, if you're looking at a recorded version of this webinar, these dates might already be over. Then I recommend you to register for our video library. Here you can access previous webinars. Now coming to the end of my active presentation, I just want to show you again my contact details. Of course, if you have questions, you can also ask me questions. Now, before answering some questions to the whole audience, but also specifically to certain people who has asked questions, I want to thank you for the attention. Of course, if you like, stay online to hear the answers to the questions. Otherwise, I wish you a good day, or good evening, good afternoon, depends on where you are, and thanks for the attention.